Welcome to Next Gen Manufacturing. Today, we are pulling back the curtain to reveal the invisible blueprint, the hidden architecture behind some of tomorrow's most incredible technology.
So let's start with a question. What could a massive automated factory on the ground and a high-tech satellite orbiting Earth possibly have in common? I mean, they seem like total opposites, right? But believe it or not, they share a fundamental secret, a core process that makes both of them a reality. And here it is. It's called the phased engineering process. Now, that might sound a little technical, but it's actually a pretty simple idea. It's a structured, step-by-step method that lets engineers tackle unbelievably complex projects and turn them into a reality. This is how we build the future without getting totally lost in the chaos. So here's our game plan for today. We're going to follow an idea from its first spark all the way to completion. We'll start by seeing how engineers tame complexity, then how they forge the all-important blueprint, assemble the team of experts, actually build the thing, and finally, how they master the risks that come with it. Okay, let's dive right in. Before you can even think about managing a massive project, you've got to learn to speak its language. It's all about taking a challenge that seems impossibly huge and breaking it down into pieces you can actually handle. And really, it boils down to two key words: phase and milestone. Think of a big project as a long road trip. The phases are like the major legs of the journey, driving across Texas, then New Mexico. And the milestones, those are the critical checkpoints, the "are we there yet" moments, where you stop, check the map, and make sure everything is perfect before you keep going. You can't start the next leg of the trip until you've hit that milestone. They're like non-negotiable quality gates.
All right, so now that we've got the basic structure down, let's get to the most critical part of this whole adventure, forging the blueprint. This is where an idea transforms into a detailed plan, long before anyone picks up a single tool.
Now, check out this number because it is absolutely mind-blowing. A staggering 70 to 90% of a product's entire lifetime cost is locked in right here during these early design phases. Think about that. The decisions made on a computer screen at this stage will determine the budget for years, even decades to come. It's why getting this part exactly right isn't just important, it's everything. So this is kind of how it works. It's like a funnel. You start really broad with preliminary studies, or EP, where you just define the big picture vision. Then you narrow it down in preliminary design, or APS, where you look at different ways to build it and pick the best one. Then comes detailed design, or APD, where every single nut, bolt, and line of code is specified. And it all culminates in the project studies, or PRO, which gives you the holy grail, the definition dossier. That's the final, ultimate blueprint for manufacturing. And the philosophy that guides this whole process, it's called systems engineering. You can think of it as the art of making sure all the different puzzle pieces, the mechanical parts, the electronics, the software, don't just work by themselves, but that they fit together and work in perfect harmony as one single system, from the day it's turned on to the day it's retired.
Okay, so you've done it. You have a perfect, detailed blueprint. But, you can't build a smart factory in your garage. So the next big question is, how do you find the absolute best people to bring your vision to life? How do you assemble that dream team?
Well, you guessed it, there's a methodical process for that too. First, you create what's called a Tender Dossier, or a DCE. It's basically an incredibly detailed help wanted ad. Then you find qualified companies and invite them to submit a proposal. You carefully benchmark all their offers, looking at both the technical solution and the cost. And finally, you sign on the dotted line and make the partnership official. And this right here is a golden rule. It's a critical warning. If that initial request, that tender dossier, is vague or unclear, you are going to get price quotes that are all over the map. And why is that? Because if suppliers have to guess what you mean, they're going to price in that uncertainty to protect themselves. Being crystal clear from the very beginning saves an absolute fortune down the road. The contracts are signed. The A-team is assembled. After all that planning, all that designing, it is finally time to build something. This is that magical moment where the digital blueprint starts its journey into becoming a physical reality. The process kicks off with something called VISA. No, not for travel. It stands for Validating the Execution Plans. Basically, you're double-checking that the contractor's plan to build perfectly matches your master blueprint. Once that's all approved, the project moves into DET, which is the hands-on, day-to-day supervision of the work, making sure all those different components come together just right.
So how on earth do you keep a multi-year, maybe even a multi-billion-dollar project from going off the rails? Well, this is basically the project manager's cockpit view. They are constantly watching these key indicators for the schedule, the cost, and any risks. They use tools like critical path analysis to know exactly which tasks are so important that even a one-day delay could delay the entire project. It's how they steer the ship. And that brings us to our final and maybe the most important section of all, mastering risk. When you're building next-gen tech, you're often pushing the boundaries of what's even possible. And in that environment, making sure every single person stays safe is, and always has to be, the #1 priority. The whole foundation of safety management starts with a really simple but powerful idea, defining the hazardous zone. It's any area in or around machine or process where someone's presence could put them in harm's way. And during assembly, a factory floor can be full of them. So to manage this, engineers follow a 3-part safety mantra. It's simple, but it's incredibly effective. First, you identify. You meticulously pinpoint every single possible source of danger. Second, for any risk you just can't get rid of, you protect. You build guards, install sensors, create strict procedures. And third, you train. You make absolutely sure every person on that site knows exactly how to do their job safely. Identify, protect, and train. The entire journey from that very first idea to a fully functioning machine, it all comes down to this one final phase, acceptance, or AOR. This is the grand finale, where the client comes in, and together with the builders, they run a battery of tests to prove, without a doubt, that what's been built perfectly matches the original blueprint. Once it passes, the job is officially complete. So, this phased engineering process, it's this powerful, mostly invisible framework that's quietly building our future. It's behind the scenes at the clean energy plants, the quantum computers, and the next generation of spacecraft. So the next time you see a piece of truly amazing technology, just take a second and ask yourself, what incredible unseen blueprints made this possible?